Thank you. Okay, so it's been a very exhaustive session last three, and we have been taken through what is MATLAB, how to install it, how to do basic, arithmetic operations. Uh, Today's morning was very elaborate in terms of writing a function, script files, and all. So this is continuation to what we have been doing. So we will start from basics though. The idea here is how to plot simple XY line curves and then extrapolate it and see how 3D plots can be done. Uh, Having said that, we will have in realistic conditions plots available with us. We would like to fit some data to that. We would like to write an expression for that, right? So, for example, you do uh, uh, your body weight analysis for over a period of 1 year, let's say. Every month, if you're ambitious, you can probably do it every week, measure the body weight, and x-axis could be time, that is, or probably month. Plot a curve. Then you will see how the weight changes. If you wish, you could fit a expression for that, and then extrapolate next 10 years how it could change, and maybe you can fine tune your intake output based on that. Uh, uh, so that's as simple as that. So you will have to take data, you will have to plot it, you will have to fit an expression, find out which is the better expression. It could be an exponential, quadratic, so on and so forth. So it's a very exhaustive session. In fact, just 2D plots and 3D plots, people can speak half a day, and then polynomials could be an half a day, and curve fitting could be half a day. But for time constraint, I can't do that. What I will do is I will give you a flavor of concepts in the next 1.5 hours on these topics. I'll do how you I will program with you. You can program with me on understand how to do 2D plotting, and very important when you plot is error bars. You know why error bars are significant. Any statistical data needs to be presented with error bars. And then a very, what I would say, flash of information on how 3D plots are done. We will subsequently look at what are polynomials, how are they fit, and how to calculate roots of a polynomial, how to do arithmetic operations, and basic simple derivations. Uh, Curve fitting will be taken in the last with some examples. I try to present as much as possible with the simple examples and parallelly programming. Uh, the essence here is not to scare you. Okay, MATLAB cannot be taught in a day, or nobody can claim to have learned it in a day. It's a calculator. I can give it an analogy. So even now, my calculation skills on the calculator is just limited to what I did in engineering courses, right? So it has many more operations which uh, I have may not have used, but that doesn't mean that the calculator cannot do it. So it is for you to explore very basic operations and simple English. Please refer Amos Gillat. It takes you through very simple. I think yesterday Narahari sir also and Devraj sir also told you about this. If you want a little higher ones with engineering problems, you can refer Dukipati. It's also good. And one by Professor Rudra Pratap is equally good. It gives you detailed information, and also the codes available in the book. It comes with a CD as well. There are a whole lot of books available online in Amazon, Flipkart. You can buy it. You can also install a MathWorks app, and scroll through the commands. But before all this, I would like to give you a hint that everybody learns now these days by Googling, right? So for that, you should have some fundamentals, and then depending on the necessity and requirement, you Google. MathWorks website is very handy. Okay, mathworks.com. Go get the commands, read the syntax, type it, and you will be easily sailing through this MATLAB. But for all that, fundamentals are important. You can also watch YouTube videos, lectures. I have just given one such link. There are many such links there. You can also refer Amos Gilat with that, and you can do not just 2D plotting, 3D plotting, extrapolation, and then interpolation of the data. And you can actually simulate.
There is some audio disturbance.
Uh, Somebody probably must mute their mic from their side. Please do that. Right. So when you think of a 2D plot, a plot is never complete without some of the things. You know, a plot will have y-axis, x-axis, and then some data points. So, but if you just present that, it doesn't make sense at all. You need to say what x-axis stands. You need to put grids there. You need to have uh, x-axis and y-axis labeled. Units should be indicated. What is this plot for? And if you are plotting two or more graphs in a single plot, you should indicate what each line indicates. And then you might have to change the size of the marker, types of markers, so on and so forth. So it's a complex process. There are so many softwares available exclusively for plotting. So MATLAB, if you're just using for plotting, is a little cumbersome, laborious work. You may better opt for other softwares. Excel is very good, Origin, and so on and so forth. But along with your program, many other, like Simulink, if you are using control systems with, together, which if you want to plot, then MATLAB is very robust, right? So all these things we will look at in our presentation. Okay, so when you want to plot, you will look for data on x-axis and y-axis, series of data. It's an array of data, right? Sorry, it's an array of data. So the syntax is plot x comma y, where x is a vector. It's basically an array. See here I have indicated 0.1, 0.2, 0.3, 0.4, 0.5. These are data sets. It could be time, and y is another array which could indicate your weight or my weight or probably strength of the material that you're testing. So you could have a variable, dependent variable on y, right? So when you use this syntax and run, you get a plot like this. So this is the data, and I have just copy pasted it. I will do that right now. I'll start doing it along with you. So you get a plot like this. You see, I've just typed plot x comma y. X is given, y is given. It gives you a line. But what I want is data sets. Like I have 1, 2, 3, 4, 5 data points. So I want a marker. So here is 1, 2, 3, 4, 5. So what do? What do I do? This whole one line, what I would say, depiction tells you what you should be doing, right? So if you want both, what you should do. So plot x comma y is a very simple, very, what I would say, basic command. But you can put the type of line, the width of line, or you want to put the properties of the line next to the xy command using the open close quotes, right? So if you look at an example that we have done, what I will do is I will just copy paste this and run it in what I use is online MATLAB. Okay, so this is online MATLAB. You need to have an account and open a script. This is easy. You can try with me, right? So what I will do is I have a data points. I will take this command. You should try with me so that we both are comfortable. I'll take x is equal to copy paste for the quickness, and I'm just copying paste. Okay. So x values are entered. I will, right? Yeah. Now I would want to enter the values of y. Please try it along with me. my slides are less and time is sufficient, so you can, right? So next, what did I do? Plot X. See, it keeps prompting you how you should be entering. That is the beauty of MATLAB, right? So you just have to see, you can read along the other options as well, right? How do you read from an external document if you want to plot? So, right now, if I say, because I'm writing it in a script file, I will have to save it, and I'll give it a name, plot 1. See, let me take, okay, now run it. Okay, so yes, sorry. So then this is the best one always, right? So I think you sensed what happened. I think something to do with the save as. Maybe it's not taking 1, 2, 3. Okay. X comma Y S, save and run. Line 3 Y. Something 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Dimensions are mashed, but it's not plotting.
Normal command window we can try, sir. I got it.
Yeah, then why is it not coming? Let me.
No, sir, I don't.
Yeah.
I think you
Sir,
delete the
probably a semicolon at the end, sir. Plot.
Anil, you
No,
delete
no.
the plot.m file and use it.
Then you have to delete the plot.m file.
No, he has defined A
You have
and B and
named
he's
it as
plotting X and
No.
Y.
No.
That's the error.
No.
A and B.
if you see that plot.m file, right?
In
That
the
has to be
directory, there is a plot.m file. He has to remove it.
Oh, yeah. This is the one.
Rename.
Now it should run.
Yes.
So this is the best way to learn. Anyway,
Yeah.
thanks to KRV sir.
Yeah.
It should run. Yeah. So we have a plot here. Yes.
Yeah.
Okay. So now I would like to have different methods. What I said was I would want to have markers like this, star. So what do? I will put a marker, or probably you see the line is gone, so you get the markers. But if you want both a line and the marker, yes, so you can play around with that and the color of the line as well. So I'll go back to the presentation. Okay, so you can play around with that, types of lines, types of markers, and get different kinds of lines. What I've done is I've entered X values here. It is the year. You can use, I think in the morning or probably yesterday, you were introduced to linspace command. If you want to enter data, you can use linspace or arithmetic progression commands. So X values are entered and Y values are entered, similar to the way we saw just now. And then we use the plot command, X and Y. So here we would like to have a red line, which is dashed line. So I used dashed, and R indicated red, and star is the marker. You see, that is the line specifier. Now, you want to have a thick line, thin line, you can define it as line width. Next, you put a comma, put it in quotes, right? And line width, you may define any thickness, 1 to numbers that it can take, and the marker size. So marker size is this size. You want to very big, very small. So this is basically the syntax. The best way to learn this syntax is to go to MATLAB and ask it to help you. You see various types of plots that MATLAB can plot and how the syntax is to begin. This is what I was saying. So dot dot indicates that it is the continuation going into the next line, right? So it means basically a single line. You can continue it. So you can do K indicates black. So color is K is represented by black. So you can plot various types of lines. You can plot markers, and so I think if you want to plot with the colors, you should. This is the book. So I think I have already given it here in one of the slides. What color, what lines? Yeah. So I'm sorry, I have not given the colors of the lines, but the book here clearly indicates what color line. Just give me a moment. Because I remember where exactly we start. So yeah. So if you want to go for a red line, use R, green line G. So these are the abbreviations or the short, the letters that you got to put it here. You can use R, K, Y, W to get different color lines, different types of lines. And if you want to have different types of markers, you can play around. This data will be helpful when you are plotting multiple graphs in one single graph. This book is quite neatly explains all the commands that you would like to explore on this. So this is just a flavor for you. You see line style, how to give that, right? So now let's move on and see how this graph can be created. So what I will do is I will just copy paste this command. So I will enter X values again. I will, right? And then I will enter what is happening. You should follow this. Maybe then you will. Now what is happening? I created an array from 0 to 10 in steps of 0.01. You can also use linspace and define how many data points you want. And an equivalent size Y array is created for every value of X. So this dot operator is very important here because this defines that one row matrix for every value of X you take is solved for that expression and Y value is entered, right? Then what do? I will plot Now there is a problem here. It says invalid character, right? So I will save it, close this, and run. It gives you the value of all x and y, and then gives you a nice plot. So this command window gives you the answers of all y values for the x values that you have input, right? So there is no way that the dimension of y will not match the x in this case. Instead of manually entering y value, you better look out for an expression that will link x. So that is the easiest way instead of entering y. Otherwise, the dimensions do not match, then it will give you an error, right? So this is another way of plotting. Right, so we will go to the next one. If you want to plot a function, now what we did here was we wrote an expression, y is equal to, and then separately plotted. Now I want to make my programming quicker, more efficient. So I can avoid separately defining the function. Instead, I will directly use the fplot command like this, right? So I use the fplot command, define the function, and define the variable there. And you define the limits from where to where you want to plot, 0 to 10, right? And then subsequently marker style, line style, and all could be defined later on. Okay, so let's see how this command works. You can type with me. I'm sorry, I should give you some time. Fplot is a command. You want to read more on similar such commands, go to F. So fplot is an inbuilt function, right? So you have 3D plot for fplot, surface plot, contour plot, you see? And this is the syntax. Okay, so I have written this plot, fplot. There is no requirement to separately say plot x comma y. I've defined this is the expression, right? This is the variable, the limits between 0 to 10, and I want to use there is always a problem with the quotes there, and then I'm saying the marker should be star type. Then let's see how it runs. Yeah, so you get a plot like this. It's an exponential plot, and you can define better intervals, higher number of data points, and get even densely packed data points for smoothness of the plot. Okay, I hope you have tried these commands by yourself. Any doubts? Because I am not following the if people are writing, I may not be able to. Okay, so there is no, sorry. Okay, right, we will now move on. So we saw how simple plots can be written without function, separately defining the function within the plot, and getting the variety of curves. Suppose you want to bring in special characters, right? Strings like alpha, beta, gamma in your expressions. You see, you can use this representation. If you write \alpha, the plot will be, suppose you say alpha on x-axis, you can say \alpha in the program, right? X label that I will show you as we move on. So these are the commands that you will have to remember to get this kind of representations. How did I label the axis? Now I got this axis plot. I will have to label the x-axis and y-axis. Very simple. X label is the command. X label is the command. You say X label brackets, whatever you want to type. It's in a string. So whatever you write, even you write your name, college name, university name, it will be printed ditto. So that is the meaning of having quotes here. Similarly, I have written y label and written f of x. So f of x will be printed. And you want to have a title for the plot, right? So when you want to have the title for the plot, maybe, so when you want to have a title for the plot, you write title and it should be in the quotes, single quotes. Now you may want to define the limits of the axis. So I've defined here -1 to 12 and -3 to 4. So that is done by using the command axis -1, comma 12, -3, -4. So it's easy. Just copy paste this command. Go here. Right. So you see the color indicates a lot of things. So we should not ignore those. Color. So purple indicates that it is now syntax error free and ready to execute. I'll close this. Yeah, so I've got the title of the chart. I've got the title of the chart. And just to your remembrance, I'm using an online MATLAB, which means I have not installed MATLAB on my desktop or my laptop. It is running through internet. So you need to have a good internet facility and it will be stored in the MATLAB drive in my user name. Okay, so you can access from wherever you go and all provided you have internet. So I have labeled x-axis, I have labeled y-axis, I have labeled the chart. So you can explore many options in this. So it is difficult for me to give you insight into every aspect of plotting. Plotting always is user dependent, how he wants to present. Based on that, he will look for the commands, and it is for you to explore once I have given you a hint. The next issue is to look for multiple plots in a single plot. How do I do it? Let's take an example. Always it's better to work with an example. I have an expression of this form, right? And I would want to take the first derivative of it and the second derivative of it. And I want to see the behavior of this between -2 to 4 interval. Now, I would like to compare all that in a single plot, like something like this. How do I do it? Similarly, similar to the way we did before, we start entering the values of x. X is between -2 to 4. So you can use linspace or the arithmetic progression command, -2 to 4 in steps of, see, -2 to 4 in steps of 0.01. Why did I give 0.01? You can give any step. The idea here is to have a smooth curve, right? The smoothest. The curve can be smoothest with higher number of points. You can also give 0.001 or 0.1. It's up to you. And this expression is taken from here. This is defined in the problem statement. I told you just a slide before that you can use fplot command. In that fplot, you put an anonymous function at the rate and put the expression directly, put the limits and plot it. You can also do it this way. And I take that first derivative, write the expression, second derivative, write the expression, plot x comma y. It will plot this. I want it in red line, so I've defined the line. I want it in the continuous line, so I've written R. So x, y, R, this curve. Okay. Now, in the same plot, I want x, y, d, that is the first derivative. it will be in green. It's all user defined. I mean, you can define any color. So this is the first derivative. And this is the second derivative. For all the derivatives, x is common. So that's why I'm sticking on to the same plot. Right? So this line is for a change I have represented using colons. So that is this line. You see? Right. There are many ways by which you can plot multiple graphs in the same plot. This is one such thing. If you plot using hold on, hold off command, how do I do it? It's important that we must be aware of these two commands. Here we have not used hold on, hold off. Hold on is to tell that if I don't use hold on and if I plot like this, so what I've done is I have up till here I'll come same, okay, and then say plot xy in red. So it'll plot this. If I don't say hold on, it'll plot one over the other. So this will eventually erase this plot and you will get only two lines or probably one line, right? So what I will do is I will copy this. Somebody wants to try it. So I've defined x value. Then
Anil,
yeah.
they wanted this to be pasted in chat box so that they can also try it.
Okay.
If possible, if possible.
Yeah. No, what I will do is I will okay. I will plot it. Right? So this I will close. I will go to chat box and please try it. You can explore various options of plotting and see how it works for you. In the meanwhile, I'll continue with the exercise. Right? So I have plotted it here. Right? So I can use, if I just want to clear the command window, I will use the command CLC. It clears, and then I will save it and run it. So what has it done? It is now plotting all the three in single plot. Right? This is what we saw. The governing expression for that is this here. That is the expression, first derivative, second derivative. And you're plotting it in red color, green color, and black color. Red color, green color, and black color. K represents black. Now, I would like to use the hold on and hold off command. Okay. So how do I do it? What I will do is I will take this off. I will say plot only red one, hold on the graph, plot green and black, and hold off. Right? So let's see how it goes. I will close this. Yeah. So what I should do now is, for our understanding purpose, I'll comment all these lines. This is the command which will not execute. I'm not executing this line, right? So it came here and plotted. It came here till plot and plotted this line. Okay. Then it said hold on. Okay. So it said hold on and then plotted. You see, it plotted the other one. It will hold on. And then you are removing the hold off. for the program to continue. Now any other plots will override that. So I will share this command with you. Please try it. I encourage you to explore on this, use fplot command, use anonymous function, and then explore it, right? So what I'm trying to say is, instead of using this expression, you can use this command. Subsequently, we will see how to use derivatives of the polynomials in the coming slides. All right, some more to explore and analyze. I told you how to write theta in radians. You see, backslash theta gives you theta symbol in radians. So you want to write sine theta, how do you write it? That's important. So you should explore this also. But before that, there are two interesting new commands that I would like to introduce. In a plot, suppose you want to draw SFD-BMD, you would want to draw a reference line. There are various ways of doing it. Ref line is a very easy and what I would say quickly available command. First one, it indicates y is equal to mx plus b. This is m, this is b. So both are 0. You draw a quick horizontal line. So you can try this command also. I'm trying to compare sine curve and cos curve. I think Rammohan sir has said it right. MATLAB help and MathWorks, if you have both and the urge to learn, you don't need any book, because theory is there in so many books. You can take the strength of materials, start writing the expression, use mathworks.com, go to their website and start executing. So you please try this out in your MATLAB. See how line 3 error. One. Okay, let's see. Yeah, so there's no error for me, but what must have happened for you is uh, this one potential, and the other potential error is use of sine command. You got to be very careful. See, here x is in radians. If you want in theta, you have to use a sine command, right? So you should be very careful. I'm sorry, just lost. Okay. Just go type that and ask for it to help. You see a sine, it is in theta. No, sine inverse, and this is in theta, I'm sorry. Right, so you can click on that. It will take what it means. Sine d is in arguments is in degrees. Here argument, that means x is in radians. So 0 to 2 pi, 100 data points. You can take 200 or you can take lesser. It is all dependent on how smooth curve you want to get. Is that, I hope it's clear. In fact, here we get it in a small window, but if you have installed MATLAB in your, you'll get it in a bigger window. You can also do it here. I don't want to do that. You can move your cursor on the plot and get the coordinates. Right? So please try that. Axis is a command that defines the limits of x and y, 0 to 2 pi here, and minus 1.5 to plus 1.5. Reference line is this line. If that line is not there, you won't get. If you want to experiment, you can just put percentage and see. You see there will not be any reference line. Okay, so but one thing you must understand here is I have not defined colors of the line. So default, it will take blue, and subsequently it will change the color. Okay, so that is about. I hope people have tried this and got the plots. No issues with that. I'll move on. Yeah. Okay. Okay. So I will move on. Now, this is very important. How to plot with error bar, because I often see that, especially with the project reports and presentations, error bars are not indicated. It is not permissible to accept such work, because error bars indicates how many trials you've done, what is the scatter in the data, and how you have fit the curve. You see, there is each point having maybe 2 or 3 trials. This is the error bar. So your x may vary. I mean, y plus, y minus need not be same as it is done here. Y minus is different from y plus. Y minus is different from y plus. Here, y plus, y minus are same, but every data set has different scatter. So both are important for us to plot. How do I do it? Simple. Error bar is the command. Error bar, and this is x data, that is this. This is y data, that is this, sales. Then I say y negative and y positive, right? So y negative, y positive. You can also do x negative and x positive, which is not plotted here. All that I've done is negative and positive. Y negative, this is the y data, year and sales of that person, and y negative, y positive. By default, it is y negative, y positive. So I have stopped at y. There is no x scatter. You can also do it for between 90, in a year of from 88 to 92. Let's say 4 years. Then you will have x scatter also. For more, please refer this MathWorks. I keep saying MathWorks is a beautiful website which gives complete information on the command, syntax, and what I would say, similar such commands which could be of great help, which you may not be aware. Okay, so please try this out. Error bar. You can go to help. You see, it keeps prompting me there, and when I hit error bar, right. So how is it given? Y negative, y positive, x negative, x positive. So it's for you to try it out, such options. We'll move on. You can also plot various types of plots. What I have shown is a linear plot, something like this. What I have shown is something like this, which we had both linear. But if you have y logarithmic and x linear, the command will be a little different. It says semilog x comma y. So which means x is linear, y is logarithmic, right? And if you want to have the other way, meaning x is logarithmic and y is linear, then you say semilog x. Semilog x indicates x is logarithmic, and you did plot x comma y. Please, I'll give you a minute if you want to try it out, or probably you take a snapshot and try it out. semilog y, semilog x, log log, right? So very simple, semi log y, semi log x, log log. So you will have various types of plots that can be easily done using one command, right? So I'm not giving you too much on this because we have almost exhausted 1 hour on this. If you go to MathWorks, this is the website. The beauty of this is uh, if you go to this web page, click on each link. This is basically a link. It will take you, these are the kinds of plots you can do, and not necessarily only this, you can do much more than this. If you want to plot a histogram, click on this. It will give you the syntax, it will prompt you how to do it, and you can explore that. You see, maybe for people who are interested in 3Ds, they can explore this, surface plots, heat transfers, something like this. So I told you log log, semilog x, semilog y, right? So I was just giving you a flavor of how plotting can be done, and please go to this website and explore. All right. To give you a simple indication of how 3D plotting can be done, again, I tell you, there are very nice lecture videos on the versatility of 3D plotting in MATLAB. You can access that. One such link is shown. There are many such links. Uh, you let's suppose you have a surface where the ball comes down to a point, or you have a system where you are ejecting from the center and it goes up. So what is the path traced? So you have x-axis, you have y-axis, and you have z-axis. Yeah, there are so many uh, uh, engineering problems. You can think of the change in stress strain curve with respect to temperature, the change in the projectile of the particle with respect to the wind velocity. You have so many problems which will have you to plot, which will require you to plot in 3D, right? So the easiest thing that you can think of is the plot 3 command, and bring in x, y, z here. That's it. I am wanting it in a black line, so k, line width is 1. So label x, y, z. And grid on is just an optional. You can avoid it if you wish. I will share this command. Yes, you can read the Excel file as well, but the best way is to read, save it as .text, and access the data from there. Okay, there are commands for that. I have not made it part of my presentation, but you can explore, right? So you can read data from, yeah, you can read data from that and explore. So please try this out command and hope it works. You can store the data in text or CSV files, and I hope the participants, yeah, you can access that file. Yeah. If the data size is less, you can simply copy paste that in your program and run it, execute it. If the data file size is like, say, 1,000 and odd rows or so, then you better access through an external file. That's better. There are commands for that. All right, we will proceed. you can try various uh, such 3D plots. Okay, we will now go to polynomials. What are polynomials? What is the use of a polynomial? How is it relevant to us, especially in the current scenario when we are talking about COVID-19? How this data is used in predicting what is going to happen. If you look at this website of IISc, they have predicted a model which they call it a 6D model. You click the time bar here till next 23rd of March. It will predict what kind of spread can be expected in various states. It's a huge information there. Now, all this are done based on some statistical data obtained. Then a curve fitting is done. You obtain an expression, and that expression is used to predict what could happen in the future. Now you can bring in AI, you can bring in other kinds of data, what I would say, uh, uh, generation, data refinement, so on and so forth, to get better prediction. But essentially, it all boils down to data generation, data analysis, and fitting a curve for that. In a polynomial, generally we have an expression where we will have the coefficients of the expression. For example, you take this expression. These are constants, right? They are real numbers. I can call them A1, A2, A3, and so on. And these are the variables. That could be time, and you could have various models. For example, this is a data that was, I found it very interesting in a study where they said they did a head count of the sharks. After every year, they found that this was the number of sharks in that particular water body. Now, you would want to fit an expression for that and predict what could happen in 8th year, 10th year, 15th year, presuming that it follows the same trend. There could be a disaster, that could be some kind of a sudden stop in the activity that's beyond the prediction. There are also predictions for that model, but hoping that this is trend, you can predict for the 8th year, 10th year, and so on. Now, how do I fix what order expression for that? Now, for that, you will have to do some basic study on finding degree of a polynomial. Like you see, he has taken this data, taken the difference of it, again take the difference of it. You keep taking the difference till it becomes constant. All are one. So now you have first order, second order, third order. So this data varies as per third order polynomial. That is how. So I'm not going to delve on that. It's not the purpose of the talk. The purpose here is I have a data. How do I fit an expression or a polynomial to that? How do I get such an expression? So by putting 8th year or 10th year, I can predict what is the shark population. That is SP here, shark population. X is the year. Okay. Now, you can think of such expressions in our stress strain plot, in our particle behavior in a fluid, or you can think of varying strength with respect to hygrothermal effects, right? So you can fit an expression for that. So the famous expression is the Hooke's law, right? How do I fit a polynomial or a exponential curve for that? So how do we represent, given a polynomial, how do we solve that? To solve a polynomial, first we need to understand what is the order of the polynomial. What are its coefficients? If you come across an expression like this, 8x plus 5, now this has two constants. Here x power 0, here x power 1. So this can be represented as, this is some arbitrary designated. I just write it as p. You can call it as A, B, C, D, anything. First and second. First row, first column, first row, second column, right? Now you have a quadratic expression, 2x squared minus 4x plus 10. How do I represent that? MATLAB, in MATLAB. I write the coefficients 2, minus 4, and 10. Similarly, look at this expression. This is where we tend to make mistakes. 6x squared minus 150, which means there is x power 0, x power 1 is missing. You see here, 0, x power 1. So you can't afford to miss that column. I say 6, 0, minus 150. Similarly, if you have an expression of the fifth order, x power 0, x power 1, right? X power 0, x power 1, x power 2, yeah, 0, 1, something went wrong here. It should have been the other way. So basically what we are trying to say here is x power 0, x power 1, 2, 3, 4, 5. 5x power 5. So this should have been 6x squared. I'm sorry about that. Okay. So just explore that. So that is how it is written. So the moment you write this like this, the computer now knows that it is 5x power 5, 0 x power 4, 0 x power 3, 6 into x power 2, 7 into x power 1, 0 into x power 0. Computer knows that. Okay. Then you can subsequently do calculations. For example, we have an expression here. It's taken from a book. The polynomial is defined as follows: x power 0, 1, 2, 3, 4, 5. The fifth order polynomial, or the degree of the polynomial is x power 5. So I will take out the constants and I will define it like this: 355.8 is this 355.8, right? Minus 71.95, that is minus 71.5, 17.1, 40, and I give it into the value of p. And the question says, for the value of 9x, what is the value of the polynomial? All that I have to do is define p. For value of 9, what is the value of the polynomial? Right? So what you should do now is, along with me, just copy paste this command, go to yes, using, you see, we have friends. So what I will do is, now the value of the polynomial p at x is equal to 9. And I will run it. It will return, the answer is 7.26 into 10 power 3. 7.26 into 10 power 3. So that is the value of the polynomial. Now, the problem also says you plot the value of the polynomial between minus 1.5 to 6.7, which means from 1.5, the value of x, to 6.5. How does the y-axis change? Very simple. Again, what I will do, I have already defined p. I don't want to do that for polynomial value of 9 now. That is done. I will take the x interval between 1.5 to 6.7. Oh, it's minus 1.5. Yeah, minus 1.5 to 6.7. For every value of x, p will be solved and will be stored in y. Is that clear? For every value, x becomes an array like this. Okay. So what we did here, we said p is an expression. Now it knows p is an expression. For, see, I have defined between minus 1.5 to 6.7 at the steps of 0.1. You can have more points or lesser points also. For every value of x, it will define y value. and then plot it. This is the plot. I think people can try it and define the step size. I have given 0.1. You can put star. You can take lesser number of points. You can play around with that. Yeah, please try this. You can explore the step size here. You can explore the kind of plot you want, the color, the markers, so on and so forth. I'll give you a minute. I have purposefully commented this line because I don't want it to solve only for 9, right? Hope people are getting it. Just copy paste that, right? Now, when you talk about a polynomial, it will have roots. What is the root of a polynomial? If you take a quadratic expression, it will have two values for x, which will go and tend it to 0, right? And for this expression, x squared minus 2x minus 3, at x is equal to 3 and x is equal to minus 1, the expression goes to 0, right? Now, in MATLAB, you can find out the roots just by typing roots command. You see, 3 and minus 1 are the roots of that polynomial. So roots is the command. P is the polynomial. You write the constants of the polynomial and tell roots. It returns the values of the roots. That is this. Suppose you know the roots and you want to find the polynomial. How do you do it? Very interesting. Yes, it's given me the constants of the polynomial. So x0, 1, 2, 3, 4, 5. 1 into x power 5 minus 12.1 into x power 4 plus 40.59 x power 3 minus 17.01 x power 2 minus 71.95 x power 1 plus 35. This is the expression given the values of the roots. So you can do either way also. If you know the polynomial, you can find the roots. If you know the polynomial, you can return the value of the polynomial for a particular value of the variable. If you know the polynomial, you can find the roots. If you know the roots, you can find out the value of the polynomial. I hope we are not going too fast, right? So that is written here. Okay, so this is the expression. I know the roots, from that I get the expression. So you can carry out simple arithmetic operations of polynomials. You can say, you can define P1, what is it? You can define P2 and say P1 plus P2, it will written. But here, we have to be very careful to define the order. Can I expect the this? I think somebody is cross-talking, so please. Okay. What I wanted to say here is, you have two polynomials, you want to add it, right? The first thing that you will do is you will type this, right? I will just, let's see. Okay. P1 is 0, 1, 2, 3, 4, 5, 6, x power 6, right? P2 is 0, 1, 2, 3. But if I write just that and do away with this, what will happen? We will try both. I think you should also try. This is the correct way, you know, it will add 40 to 6 it'll add 15 to 2, 3 to 0, and likewise. But if it were, if you, in the excitement, if you had done this 0, 1, 2, 3, which is fine, but MATLAB won't understand how to add. It'll say error. This is very important. We learn from errors, you know. Right in the first presentation, first minute of my presentation, I learned something. Although it's not that I didn't know. Right. So what should we do? We should always match the orders. So here 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6. Then you're safe. Right? I think the participants have got the sense of how important it is to match to get the addition. Similarly, you can do P1 minus P2. The same rule applies. You got to stick on to that thumb rule that the orders, size of the orders must match. Right? So P1 minus P2, ensure that the orders match. Right? I will move on to multiplication. Multiplication is even more straightforward. All that you have to bring out is the command called con, which is nothing but convolution. Go to help, type conv. It'll prompt you how to carry out the coding. Okay, so you have two polynomials p1, p2. Don't worry about the order or anything. Just hit it and solve it. Okay, right. So what I will do is so p is equal to con p1 comma p2. So it's given me some junk in, junk out. Okay. So it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninth order polynomial. But let's see. 1, 2, 3. What will happen? You see that? So it's still a ninth order polynomial. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But it has no sense. Right? So if you carry out hand calculation, you will know what it is its meaning. So please make it a note that you will use convolute command to carry out multiplication of the polynomials. You can also use deconvolute command, that is deconvolute, if you want to divide P1 by P2. When you do division, you have a quotient, remainder, dividend, divisor, so on and so forth, right? So P1 divided by P2 will give you a quotient and a remainder. This is exactly how the MATLAB does it. So here, when we start dividing, you will have, so for example, you have P1 here, or it's called U, P2, that is V. Now you have a matrix given here. Why? Because Q will store the coefficients of the quotient. It could be nth order polynomial. And R will store the quotients of the remainder. It could also be an nth order polynomial. So how do you store that? By Q comma R. So you got to define that, right? So please try this out. Same P1, P2, command C. I copy it. It is there, right? So I've defined it. Sorry. And say there will be something extra. Okay, let me do with this because I want to show that error and explain. So let's see what. Okay, so I save it and run it. So it's given the quotient 0, 1, 2, it's a quadratic expression, 2x squared plus 3x minus 2. That is the expression of the quotient, and there is no remainder. Please keep it in mind. So there is no remainder, you get only the quotient. And in some excitement, if you type like this is the problem which we had solved in addition and subtraction, remember? So if in your excitement, if you type like this, okay, done that. And later on what I will do, I will use the deconvolute command. Why should that error come? The question is, why should the error come? This is important because, as I tell before, error comes because of these zeros. Never keep zeros in the beginning, which means the first row, first column must never be 0 in your division process. Okay? Now run it, you get the value. So you have the quotient, you have the remainder. So deconvolute is the command used to execute division of polynomials. So I have this expression written here. I'm going to divide that by this expression here, you see, and I'll get a, I think this is the quotient and this is the remainder, right? Okay, so derivative of a polynomial. You use the polyder derivative, you define what is the p and polyder. You can quickly solve that. This is the expression. You define f1, you define f2. Just type polyder, you get the derivative of polynomial. And if you write polyder f1 comma f2, it is going to multiply these two polynomials and then give you the derivative. Such an, I think, far-sightedness, people saw that. So you would want to multiply two polynomials and then take the derivative. So polyder f1 comma f2. These are commands which you got to explore. And see, if you remember in one of the earlier slides, I told you that y is given, then yd, ydd, right? So instead of that, you can try this polyder. You have the polynomial, you keep the derivative, and you will get the same plot. I think there is short of time, so we're running out. So I will just keep it as short as possible, right? You see, this plot, if you remember, I had done it in the initial phase of my presentation. I have physically written the y first derivative, second derivative. That I have done using polyval. Polyder here, polyder, right? So you can try it out by yourself and see what plots you get. Oh. Something wrong? I'm not able to. I was not able to. It's not pasting. Maybe I should. Okay, I will copy paste from here and please try this. How about the linspace and all? You can try the linspace command instead of arithmetic progression. That's what I was indicating. It will certainly show error if you type like that, right? So it's for my presentation purpose. It's for you to explore. Okay, we got to move on and see the last part of the, this ends the, you can try the hold on, hold off and all. We go to the curve fitting one. Now, curve fitting is a big exercise by itself. So you have a polynomial, you have xy data, you plot it, and you want to find out what kind of plot, y is equal to mx plus c or higher order plots. It all depends on the perception of the individual user, right? So what I will say is fit, right? Polyfit, xy data, and what is the order of the fit? Is that clear? That will return the vector again of the expression, polynomial expression. Suppose you have data set and it is matching y is equal to mx plus c. So it will return m and c, right? So that m and c will be stored in the vector p, right? So n is the degree of the polynomial. Here I want first degree. So you get mx plus c. So m and c will be stored here. Let's look at this. I, from some experiment, have this data, x and y. Please try it up quickly. And as I explain, you will visualize what is happening. Be careful with the, be careful with the colons and on so forth. This is the x data from the experiment, and I have the y data. The size of the arrays must match 1, 2, 3, 4, 5, 6, 7. So there must be 7 data here also. And I say polyfit x comma y comma n is something that you can change y, right? So it returns m and c in this p. Okay, so now that p will have an expression. Now what do? I will start please bear with me. I'm okay, right? Oh, something is not terminated properly. Line 7. This is the problem. Okay. Okay. Now I have taken some data from an experiment. Okay. It is just plotted there. Just ignore this also. If you understand this plot, then the rest of them just cakewalk. So I've taken x data, y data. I want to fit some polynomial to it. I plot y is equal to mx plus c. First, I define it as first order, right? And the coefficients of that will be returned to p. So if this is the value of p. M is 0.5688 and C is 0.92. So that is the first order. Now I take this expression, put some more data points for trial, that is xp, and yp will be the xp value, and p is this polynomial expression, that is this expression. So I get yp and compare these two, right? So this is what it's doing. It is trying to compare xy data, fitted expression versus this data, and then you plot xp yp, and you plot, let's see now how it goes. Yeah. So what did it do? It took xy data and it plotted xy data as zeros, that is this xy data, right? Then it fit an expression for that using polyfit command. It fit an first order polynomial, and the coefficients of the p was shown. I showed you to somewhere here. That is this. Now that expression it used, put some more trial values of xp, got the values of yp for that expression p, and then it plotted a straight line for that expression p. So now for this data, I have that expression, and then when I plot, I get this line. Is this clear? I will share this because very basic, but can something happening. It's not copying pasting there. The slides will be shared with you anyway, so we don't have to worry too much. So now I kept changing n here. You see, it went into second order quadratic, then third order, fourth order, and sixth order. Surprisingly, it runs through all the data by changing just n here, right? So what I do, I just change sixth order, but I want to request and suggest that this may not be the correct plot, correct fit rather, because not necessary that when you carry out an experiment, all points should be fit, right? So that may be misleading also. So I'm just showing you how to explore. So generally, best fit method is used, so you can explore it. I will share the slides with and if you want to try it out, this is the famous SN curve. How to fit it? This is the data, X data, Y data, and you fit XY data, you get an expression, and then you can find out what expression it is, right? So I will leave it open. I have to move on and explore some other options that you can fit with. You can fit a power law. This is the famous Hooke's expression, right? E strain power n, where n is the strain hardening coefficient. So you can do that. How do you do it? I'll tell you in next minute. So you can fit an exponential curve also. You can fit a logarithmic plot and a reciprocal plot. These are the ways. If you take this expression BMX, you can simplify it as taking logarithm on both the sides and get a plot like this, right? So then you can say polyfit xy of order 1. Little high to understand. What I did was in my experiment sometime back, I'll stop the presentation after this very interesting work. I took a composite. The composite had fibers oriented along a particular direction, right? So it is at angle theta. I kept on pulling it, doing a tensile test at different angles of theta. It was 0 degree. It showed about 2000 MPa. And at about 5 degrees, it came down drastically to 1400. These are not correct values, but some representation data. And as I kept increasing this theta, so much that it went to 90 degrees, it was only the matrix which was holding on, and I got 150 MPa. So the curve comes down like this. I don't know if it's a polynomial fit or exponential fit, nothing. I don't know anything. So what I did, I took the X data and I took the Y data, right? Please listen and observe. I took the X data and Y data in the MATLAB. X comma Y, and I said polyfit first order. What will it do? It will return the value of M and C. It's a slope, right? So that is the polynomial for that y is equal to mx plus c. But I told you in my previous slide, so if you have this expression, you can bring it down to logarithmic and then plot log x log y. The slope of that line is m and log b is b, right? So you have log plot, that is this, and I get this expression. So eventually I fit a curve using dashed lines, that is this. So I got the polynomials p for that, put the data points for the plot that gets you this. Then I define the axis, what axis you want, 0 to 100, that is this, and 0 to 2250, x label, y label, hold on. Then this first polynomial value is m, that's this m. The second polynomial value, the exponent of which is b. You've got to go back, use a paper, and understand what is happening here. Why did I take exponent of this value to get b? You will understand because ln b is b here actually, right? And to take off this ln, I use e, I will get b. Please do that. So I get m and b from that, and I put some arbitrary values of x and replot that exponential, and I get this curve. It's a very simple exercise. I will share the data with the presenters. There are also some more data which you can try it up. With that, I end the presentation.